fun to me, yes. No, they are fun. They are. They're easy. They are. This quarter.
Is that something we've ever learned?
No.
Okay.
Okay, so everybody's okay with these? We plug them in, we check them. Those two checked, and these two also happen to check. So you're all right with those? All right, let's get down to the beefy ones. Okay. Now remember, you're solving an equation, an algebraic equation. You get past the algebra part, and then you have the trig part to do. The trig part says, I have an angle who's this. So you got to go a little step further. So once you get to here, you only did a quarter of your problem. Now, I've got to locate in my quadrants, and we start with your unit circle. Well, you're not your unit, but we start with your basic 2 pi circle. We say sine is your y. It's negative where the y is negative, third and fourth. Y over r. We notice that your reference angle would be 30. How many times does 30 go into 180? 6. So your reference angle is pi over 6. That's your reference angle. So set this up. 6 pi over 6, 12 pi over 6. And name me this angle. It goes one past there, I'm at 7 pi over 6. One before the 12, I'm at 11 pi over 6. You got 2 angles. 2 angles between 0 and 2 pi. If we look for all solutions, we do it the same way we did yesterday. We said, well, if this is my end, then I can go around another 2 pi, and another 2 pi, and another 2 pi. 2n pi. Do it for both of them. So this is all solutions. Because you know your sine curve is endless. It keeps on going both ways. So I've got an endless amount of solutions, an infinite amount of solutions. So that 2n pi, where n is any integer, takes care of any part on my sine curve that I need to get. How to get what? Pi over 6. Did you get a 30-degree angle over here? Okay, so 30 goes into 180 how many times? Pi over 6. That, you only really have your 3 angles, 45, 30, and 60. 45 is your pi over 4. 30 goes in 6 times your pi over 6. 60 goes in 3 times your pi over 3. Those are your only special ones that you know, other than your quadrants. Like 90, doesn't that make sense? 90 goes into 180 twice, pi over 2. Yeah. So it does make sense. You guys have to look for patterns. Patterns, let it make sense. Okay. This guy, solve your equation. Again, don't rationalize. It's easier without rationalizing. We're in the same 2 quadrants. Sine is negative 3 and 4. Now you have a 45-degree angle. So your reference angle is pi over 4. So set up 4 pi over 4, double it. So you're 1 more than the 4, you're at 5 pi over 4. You're 1 less than the 8, you're at 7 pi over 4. And again, plus 2n pi, where n is any integer. You want endless solutions. Just keep whipping that around the 2 pi. 2 pi, 4 pi, 6 pi, negative 2 pi, negative 4 pi. That 2n pi takes care of that. That gives us all solutions.
So we're actually like domain or something?
No, we're totally off of the inverses. That's why I do the inverses completely separate. Because it's the only time we do that. The only time. This is completely the opposite. It gives us all possible solutions. It goes kind of back to your curves. Again, this one, solve your equation. Cosine is positive wherever x is positive. X is positive over here. So cosine is positive in 1 and 2. Figure out your reference angle, 30. That's pi over 6. So this is 6 pi over 6. This is 12 pi over 6. Pi over 6 is your first quadrant angle. and 11 pi over 6 is your fourth quadrant angle. And again, plus 2n pi. Donovan?
So since the secant goes to 1/4.
Secant, no restrictions. We're all possibilities. Get rid of restrictions. We're totally the opposite of restrictions. We're endless.
How's it in the fourth quadrant?
Fourth quadrant, because this is the reciprocal of cosine, right? Cosine is your x value. So x is positive over here. So it has to be here and here.
Oh.
Yeah. I go by my quadrants instead of my all students take chemistry. You can do that too. Because all students take chemistry, all in cosine. 1 and 4. Did you get 30 for a reference angle? Okay, now, to convert 30, we would multiply by pi over 180. And that reduces to pi over 6. Easiest way is to say 30 goes into 180 6 times. Pi over 6.
So it's not like
Well, this guy, this one is first in quadrant 1. Just 30, pi over 6. This guy comes all the way here and terminates 11 pi over 6. Okay, this one, we subtract 1. Cotangent is the reciprocal of tangent. Still tangent is negative 1. So tangent is negative in 2 and 4, where your signs are opposite. One has to be a positive, one has to be a negative. So your reference angle is 45, pi over 4. So 4 pi over 4, 8 pi over 4. Now remember, we said because your tangent curve has a period of pi, we only have to do the plus n pi on this, because if you look, you're straight across the other side of the circle. You're 180 degrees away, pi radians away. So if I add 180, add 180, add 180, I just keep getting to the opposite side. So this one, I just say plus n pi. Because your tangent and your cotangent have a period of just pi, not 2 pi. So now I can just add the n pi to this. Okay? A little quicker. Tangent. Yeah. And it also works when you have 4 quadrants of things.
would you still write it the other way though, or no?
You could, but it's technically what's going to happen the other way is, yeah, I guess you could. You
Is
could.
it wrong?
I would prefer this, but it's not wrong. It's not wrong because you're still going to get to your multiple angles. And that's what your goal is, to get to your multiple angles. Okay, so we solved this equation. Now watch what happens here. When you take the square root, remember, you get a plus or minus. So you're all 4 quadrants on this plus or minus. How many of you actually caught this, that you did your plus and minus? Good. Remember, I always say when you undo the square, plus and minus. So you've got all 4 quadrants. Technically, if you did this one plus 180, you get this one. If you do this guy plus 180, you get that one. So you just have to do quadrants 1 and 2. Name those. We found your reference angle to be 30. So 30 goes into 186 times. So pi over 6 and 5 pi over 6 plus n pi. If you did all of them plus 2n pi, I mean, that is, but that's a lot of like writing them out. It's easier to condense them. Did everybody catch why we're doing this with the plus or minus? It gives you all quadrants, all the positives, all the negatives, all quadrants. So then I can just find my quadrant 1, add 180 or pi, it'll give me my quadrant 3. Quadrant 2, never add the 90s, that doesn't work that way. Just the 180s, it's got to come straight through.
How do you know when to use like plus 2 n pi or regular?
Because if you can come straight through, that's half your circle. If you're this way, that can't come straight through. So this is going to be a 2n pi. That's usually a sine or a cosine. Usually your sine and cosines are 2n pi's. Where you do have a break is if you did the cosine squared and came out all quadrants, then you can do the n pi. But tangent and cotangent are n pi because that's their period. It only takes them, if you go like this, it only takes them from negative 90 to positive 90. It only takes them 180 degrees to complete one cycle. Okay. Again, cotangent, as soon as we take the square root, we get all quadrants. Find your reference angle is 60, so 60 goes into 180 3 times. So I want to do this guy and this guy, and then I could send it through with the n pi. You always have to do your smaller one plus n pi. If you did your larger one plus n pi, you would have missed your smaller one. It won't go back. You won't go backwards. You'll go forwards. Well, I guess if you did it with a negative, you would go backwards, but you've got to start with your smaller one. So those of you that weren't finding angles, make sure you find angles on these. Yesterday we ran these side by side with your algebraic one. We said as soon as we finished the algebra part, we then had a tangent part to go through. Okay, and is this your last one? This is the last one. Okay, now here's a good one for cosine. When cosine squared, this happens to cosine squared, you can take the square root of cosine squared to give you your plus or minus. I think I missed the n pi here. And if you find this one, you do 180, you'll find that one. If you find this one, you do 180, you'll find that one. Where n is any integer, what was I saying? I just forgot the plus n pi. And so work for this guy because you have all 4 quadrants. Right? Now, we're going to do these the same way. We're just going to factor. So your goal is if you have greatest common factor, perfect square factors, trinomial factors, you have to factor them. Now, way back when we did factorings, which wasn't one of your favorite things, I said, and Alicia was shaking her head, yeah, I did say that when we get to trig, cosine, and sine, they look a lot worse. So if you struggle with this, take the words out of here. So say I make my cotangent be x. I'll make my cosine be y. What would I do for this guy? Okay, you're going to subtract the 2x, right? Oops. And now what would you factor out of here? What do they have in common? X. So you're going to factor out an x. And then can't you set both of these equal to 0? We're going to do the same thing with your cosines and your sines. And your cotangents, your tangents, or secants, whatever they throw at us. So if we struggle, take them out and look at them to the side. So now we know we got to get everything to one side. Just like we did there. So we're going to take out a cotangent, factor out a cotangent, and what's going to be left? Cosine squared minus, if I take a cotangent out of here, two. Now, these are both factors. They're different. That's okay, because they're separate factors. Set your factors, make your tree, make your factors equal to 0. Cotangent x equals 0. Cosine squared x minus 2 equals 0. Let's work on your cosine for a second. So we're going to solve this one. Add 2. And take the square root. You get a plus or minus radical 2. Now, cosine is x over r. anything wrong with that picture? When I put this over, well, square root of 2 is about 1.4. Can't be more than your radius, right? So the cosine is out of our -1 to +1 range. We don't have an angle that has this cosine. So therefore, we reject this part. Sometimes when we do this, you're going to find those situations. When we start squaring things, we're going to have to check for extraneous roots. We're going to find those problems. Daniel? Because technically, your radius should be larger than your x value. Your hypotenuse should be bigger than any side, right? But square root of 2, radical 2 is about 1.4, so it's larger. If it was my secant or my cosecant, yeah, but not my cosine. My cosine and my sines only go from -1 to +1. So let's work on this guy. Cotangent 0 must be one of my quadrant angles. Cotangent is which piece? X, Y, R, X over Y. So I'm looking for an X of 0 and a Y of 1. What's the angle? 90. Everybody see it? Do this and set it up like a pair. Which one does it match up to? This guy. Pi over 2. So in my solution, it would just be pi over 2. If I want all solutions, how would I write all solutions? Pi over 2 plus what? 2 and pi. I want to come back around. Where n, any integer. Okay? So this had a greatest common factor. We pulled everything to one side. We factored out a greatest common factor. You can't get rid of it. You factor it out. You have two factors. You set them equal to 0. And you solve. Good so far? Okay. Okay. This guy. We're going to find all solutions between 0 and 4 pi. So let's just work on the 0 to 2 pi first. Looks a little bit weird to me. So I'm going to take this out and make my sign an x right now. 2x squared minus x minus 1. Does it have a greatest common factor? No. So trinomials? Yeah. First said yeah. 2. Now, this guy is your prime number. 1. I'm sorry, not prime. It has only factors of 1 and 1. It can only go like this. And to get a negative, 1 has to be a positive, 1 has to be a negative. So all I need to position is my factors of 2. You only have one set of factors. So either this first guy is going to be a 2x or it's going to be an x. Do it in your head. Tell me which one it should be. What should this first one be? 2x or x? Do it in your head. Foil it in your head. You're looking to make sure that your middle term comes out like this. Okay, let me try an action here. X and 2x. So let me take a look at my middle terms. These are my middle terms. They make a smile. This is plus 2x. This is minus x. Ah, I need this to be the minus guy. So therefore, this is the 2x. This is the x. See it? Now won't I get a negative 2x and a positive 1x? So I'm going to put my 2 sine x plus 1 and my sine minus 1. Okay, if I stick sine x back in there in place of x. Okay, you only had one set of factors to change. It only took us maximum 2 tries to get there. So don't panic. These are not going to be real bad ones where you have to worry about it. The goal here mostly is to find the angles. If you kind of think about it, your special triangles really only have 1s, 2s, and radical 3s. So 1s and 2s and 3s are not going to really be that bad to factor. So let's set these equal to 0, make a t. solve. I'm going to subtract 1 and divide by 2. I'm going to add 1 to this side. Now let's look for our solutions first from 0 to 2 pi. So I look at my circle. Remember, these are all solutions, no restrictions. Sine is my y. Where is y negative? What quadrants? 3 and 4. So I've got 2 triangles. This is y over r. What's my reference angle? 30. So how many times does 30 go into 180? 6. So my reference angle is pi over 6. So 6 pi over 6, 12 pi over 6. So what's this angle over here? And what's this angle over here? Okay, so you just found your solution from 0 to 2 pi. But it's asking me to find my solution from 0 to 4 pi. I need to do another 2 pi to this. So if I add 2 pi to this side and I add 2 pi to this side, I should get my second solution, right? Now remember yesterday I said watch the denominators. What denominator do I need to add? 6. So convert this. 12 pi over 6. So that's what you want to add. You only want to go around one more time. So this was 1, this was 1. Now add your numerators. What do we get? 7 plus 12. 19 pi over 6. And 11 plus 20 plus 12, sorry. 23 pi over 6. So you got 2 more. So you did 4. 2 in the first 2 pi, 2 in the second 2 pi. Now let's work on sine is 1. It's y over r. So I've got a y of 1. Somewhere along my unit circle, my y is 1. Up, right there, 90. So x is equal to pi over 2. I got to go one more. Now, you can add 2 pi to that, or cheat a little. This is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I could take pi over 2 and add 2 pi. So I would take my 2 pi and I would convert it to a denominator of 2. 4 pi. So what is 1 pi and 4 pi? 5 pi over 2. Either way you like to do that, if you're only going one more circle and it's an easy one to figure out, kind of is a little easier. Pi's and pi over 2 are easy. You don't have too many of them to go through. So we actually have 7 pi over 6, 19 pi over 6, 11 pi over 6, 23 pi over 6, pi over 2, and 5 pi over 2. These are all my solutions to this problem. And you can easily check them in your calculator. You plug that in, 2 times, let's pick one, 23 pi over 6, squared minus, oh sorry, it's the sine. Sine 23 pi over 6 minus 1, got it equals 0. It's good to check. Just check a couple of them. I would check one of the 90s and one of the other ones. And check one out here, because if you got these right, then you got these right. Okay? Make sense? Okay, one more. Now, sometimes you have 2 different variables in here. You have a sine and a cosine. Can you solve one equation for 2 variables? Can I do this? 2y squared plus 3x minus 3 equals 0. Can I solve for those in one equation? No. So I need to substitute out. You have your identities that we said you should learn, and we said this one was the most important one to remember. Cosine squared plus sine squared equals 1. This is your Pythagorean one, remember? x squared plus y squared equals 1, and then we substituted it in. If I can't change cosine, that's the lowest I can go. If I can substitute this out, solve for this guy, in terms of cosine, I can substitute it in. So I'm going to subtract my cosine squared from both sides. So my sine squared is equal to 1 minus my cosine squared. So in here, I substitute 1 minus cosine squared. Does everything have a cosine now? Good. So now you have to be really careful because you have to distribute. Watch your negatives. One negative you mess up changes your whole problem. Here's another place to get messed up. There's the equal sign. Combine your like terms on one side of the equal sign first. Look, I got a 2 minus a 3. What does that give me? Negative 1. Don't add 2, add 2. Because you're on one side of the equal sign. This gives you negative 1. Watch that negative sign. Now, if you're going to factor, you want this first term to be positive. I have an equation. What can I do to make my first term positive? Divide by negative 1. Multiply or divide by a negative 1. Switch all your signs. Okay? And this actually doesn't look so bad. 2x squared minus 3x plus 1. That's what we're looking at. Again, the 1 can only be here. This isn't bad at all, because what are going to be your two signs in there? Not positive. They have to be the same, but they have to add up to a negative. So 2 negatives. And what are factors of 2? 1 and 2. So in this case, it doesn't matter. Both of these are the same. So 2 cosine x and 1 cosine x. And there's your factors. If you have trouble, bring them out. Work on them as x squared and x. Then we set these guys equal to 0. And we find our answer. We add 1, divide by 2. So let's work your cosine 1 equals 1. Cosine is the x value. Where do I find that? On my unit circle, where do I find cosine of 1? At the 0 degrees, or the 0 radians. So x equals 0. Let's just find it between here and 2 halves. Cosine of 1/2, that's my x. Where is x positive? What quadrants? 1 and x positive 4. Good. 1, 2, this guy's your radical 3. What's your reference angle? What's opposite radical 3? 60. How many times does 60 go into 180? 30. So you got a pi over 3. And this guy would be 6 pi over 3. So what would this angle be down here? 5 pi out of 3. So you have 3 solutions to this. Okay? So this is what you're looking at tonight.